So now, so please follow my lecture, okay? We discussed today about the topic of frequency domain channel measurement. Do you remember the last lecture is about the time domain, right? In our last week, we have discussed about the time domain, right? Is that correct? In the last we discussed about the time domain channel measurement. Now in this lecture, we are discussing about the frequency domain channel measurement. Yeah. So in the time domain, we measure the channel impulse response in the time domain. Yeah. In time domain, we measure the CER. That is a channel impulse response. I think that I don't need to explain about what is a channel impulse response, right? We are clear about this concept in the last our previous lecture. Yeah. And how about the frequency domain, student? We measure the channel transfer function. That is a CTF. Okay. So the CTF is a Fourier transform of the CIR, right? The CTF is a Fourier transform of the CIR. So if you take the Fourier transform of the CIR, so you obtain the CTF. CTF is channel transfer function. Yeah. So what is the channel transfer function in Vietnamese? Hàm truyền đạt, đúng không? Hàm truyền đạt. So we are talking about the measure the channel in the frequency domain. It means that we measure the channel transfer function. Okay. So concept of measurement is quite equivalent to the channel estimation. Yeah. The channel measurement actually is serve for the purpose of the channel modeling. It serves for the purpose of the channel modeling. Yeah. That is, it serves for the purpose of the channel modeling. And the channel estimation is served for the purpose of channel equalization. Yeah. Channel equalization. Okay. That is somehow similar. The two different purposes, but the work, the task is similar or identical. Yeah. There are some other concept that is channel prediction. So we did not discuss in our class, but today I focus on the concept of channel measurement. Okay. And namely in the frequency domain. Yeah. And I show you how that works. So in frequency domain, you know that, yeah, the CTF, that is a CTF. That is a channel transfer function. Yeah. And that is a CIE, CIR. Yeah, that is channel impulse response. Okay. The connection is the Fourier transform. And how we can measure the channel in the frequency domain. That is frequency domain. Yeah. Here's the time domain. Frequency domain and time domain. Yeah. And how we can measure the channel transfer function. Yeah. In the frequency domain. So the concept is focus on my explanation. Yeah, we need to transmit somehow like a pilot symbol. We need to transmit a pilot symbol. Let be in mind about the concept of pilot symbol. Pilot symbol in Vietnamese, that is mẫu tin dẫn đường. Is in Vietnamese mẫu tin dẫn đường, the pilot symbol. So the pilot symbol is inserted in the frequency domain. Yeah, the pilot symbol, the pilot symbol will be inserted in the frequency domain. The pilot symbol will be inserted in the frequency domain. So that's the concept. And how it serves to the purpose of the channel estimation or channel measurement in the frequency domain. And how does it work? So I give you here is a signal dimension in the time and frequency domain. Yeah, in time and frequency domain. So actually that is for the 4G network. And in this figure, you see that the signal is orange in the both time and in the frequency. So if you have work on the 4G on 5G, so you are clear about this concept. And now we are talking about how to measure the channel in frequency domain. It means that we need to work on the signal processing in the frequency domain. And that is our purpose. So as I mentioned before, that in order to measure the channel in the frequency domain, so we need to insert the pilot symbol in the frequency domain. Yeah. So if you see in this figure, so on again the other figure, you can see that the signal is orange in the on an example that the signal is orange in the frequency domain, and here's the time domain. Yeah, time and frequency. So if we the signal in nature form, student listen, the signal in nature form is that presented in time or in frequency domain. Could you please answer my question? The signal naturally is presented in the time domain. That's correct. And nice. Here. See, the signal nature is present in the time domain. So what I'm talking here, that is the time domain signal. So if you are listen to my voice, yeah, and you record it by using a software, then it will be automatically presented in the time domain. Yeah, it's automatically presented in the time domain. However, you can present this signal in frequency domain by using the Fourier transform. You get the point? You can using the Fourier transform. So if we want to estimate the channel in the frequency domain, then we need to transform the signal in to the frequency. We need to transform the signal to frequency in order to capture the picture or the signal in the frequency domain. Yeah. And the process to estimate the channel in frequency domain is conducted by the 3 steps. In the 3 steps. In the first step, That is first step. Is to insert, let's say, insert the pilot symbol in the frequency domain. Pilot symbol. So you need to insert it in the frequency domain. So that is that one example. It means I suppose that this is a pilot. So we are transmitting a pilot symbol in the frequency domain. That's the first step. So in the second step, the pilot symbol is transmitted over a channel or through a channel, and later on it will receive the receiver pilot symbol or to each. Can you write together with me each of the pilot symbol as a receiver? Yeah, so we call that as a receiver pilot symbol. Also in the frequency. So all the concept we are talking here, that we are discussing or we are talking on in the frequency domain. So if you want to work on the frequency domain, you need to transform the signal from the time to the frequency domain using the Fourier transform. Yeah. So that's the second step. So in the first step, write down please. In first step, so you need to estimate the channel coefficient, the CTF channel transfer function, coefficient. By using the transmitted pilot symbol and receiver pilot symbol. Namely, you divide the dividing, say, dividing the receiver pilot to the transmitted one. So I will write that is S, the channel coefficient S, equal to K. K is the pilot transmitted one to the I. Okay. Okay, and here is a ZF coefficient. ZF. So that is a force. That is 3 steps. So I stand 1 step more. The fourth step. So I will explain later. Yeah. So interpolation technique. So that's right. That's right here. So I will explain later for you. Interpolation. to recover the rest information of the channel. Okay. So the first one, I think that is I can explain later. Yeah. So for the beginning, I am explain the first 3 steps. Yeah. So please draw. Yeah. Phút here, the phút here, the big picture, big yeah. So fine, listen. Okay. Yes. Yeah. No. Yeah. Actually, not the power, not amplitude. It's a signal, a ring signal. No power, no amplitude. That's the ring signal. Yeah. So what you use what you not you what you obtain or you receive. No power. So please don't understand that is a power. Yeah. No power. Power is not correct. That is if you use in baseband, that's a complex signal. Okay. Because we are no power, right? Okay. So that's a complex signal. So you are talking on the baseband, then that's a complex signal. So the channel is complex. It includes the amplitude and the phase. So if you are estimate the channel, then we need to estimate both the amplitude and the phase. A very good question. Yeah. I want you to work on the MATLAB exercise. Yeah. MATLAB exercise. Please work on the MATLAB exercise. Number 1 to 8. So if you are working on the number 8, so you understand fully this concept. Full concept of channel estimation. Okay. Yeah. So there's a couple exercise. So I would like you work on this. So if you are work on this exercise, okay. So very good question. Okay. So that is I'm talking about these 3 steps. Later on, I will discuss about the 4th step about the interpolation. Yeah. So did you finish the writing? Or writing? So I move to the next slide. Okay. So that is a channel. This channel, I think there's also my code of the in GitHub. So you can also download and understand about the channel. Yeah. And that is a fading channel. Yeah. Not Gaussian channel, it's fading channel. The Gaussian channel is different to the fading channel. The fading channel means that the channel is the fading channel means that the channel is actually that's a multiplicative channel. And the signal is faded somehow caused by the channel. And we need to work on the equalization to recover the signal. Yeah. Recover signal. So let's say that's the first step. That's the first step. We are. I'm sorry. That is the third. The 4th step. Yeah. The 3rd step. Yeah. This one. So we dividing the receiver signal to the transmitted signal. Yeah. And regarding the system level or system simulation. So we have here is a, let's say we have here is a transmitter. That is a transmitter. And here we have a receiver. We have a channel. A channel. Okay, I'm sorry. Okay, so channel have two terms. One is an additive channel. Two terms that is additive or AWG and channel. Second one, we have a fading channel. Yeah. So before I move to the, I'm discussing about the transmitter and receiver and how to estimate the channel in the frequency domain. So I would like to ask you, what is the AW channel here? What is this? Can you explain for me what is this here? The upper elevation, that is additive. Additive. Well, why? Gauss noise. Okay. That's the upper elevation. So what is this? Explain for me in detail. It's very important to understand this concept. This one. What is this? Student. Can you answer? So if I'm working on my project, so it's very done well. Yeah. Yeah, it's correct. It's correct. It's correct. He answered a very good question. Yeah. So what is your name? Hải. Hải. Oh, Hải. Very nice answer. Yeah. So Hải answer. Yeah. Okay. Answer. Yeah, Thái, can you repeat again? Is a noise. Is a noise follow the Gauss distribution. You are at least you are better than my in my understanding before, I think 30 years ago, about nearly 30 years ago. Yeah. I'm sorry. So I'm telling you my story. So I'm going to Germany to do my PhD in 1998. So I think it's 24 years ago, right? Is that correct? Oh, 26 years ago. Okay. So fast. Yeah. And my supervisor asked me, checking my understanding, my qualification. Yeah. His name is Kuchenbecker. He's my doctor father. Yeah. I remember that is that's in the late afternoon. Yeah, late afternoon. I'm traveling from Münster to Hanover. So in the morning, I'm searching my accommodation, searching my flat for stay in Hanover. And in the late afternoon, I'm going to visit my professor at around 17 p.m. So he's sitting there waiting for me. So he asking me so many questions. I think